In week one, we talked about kind of some of the basics of soil fertility and provided a little bit of a framework or grounding in terms of how we might think about fertility. And then in week two, we're going to really jump in to thinking about fertility evaluation. And it's important, I think, that we talk about this up front because fertility evaluation is a big part of this course. It's a big part of understanding, um, what we're actually doing. And so really a fundamental piece to this is soil testing. And so this lecture really is going to talk about soil testing in particular. Let me do that. Okay. So soil testing and submitting the kind of the simple act to this simple act could be or could not be of submitting a soil sample really provides a foundation for managing nutrients. Okay, so our language isn't too precise here, but really we can think about soil testing. The way I'm talking about it is sending it maybe to a commercial lab and then having a very standard set of analysis done that is returned with some kind of key recommendations based on that. Okay, so again, second week, we're kind of jumping right into the applied component here, but I think it's a nice and useful framework for thinking about as we continue to cover the topics as this course progresses. We can look back to our soil testing and think about that. So there's really two pieces here, the soil testing, and we're going to get into plant analysis next time, but I just want to provide some basics about soil testing, okay? So you pull soil samples or maybe a set of soil samples, you send it to a commercial testing lab. There are several in Ohio, and there's plenty of soil testing labs out there. You get some numbers back and a soil test report. Depending on the lab, you're gonna, we'll talk more about this. We'll get into this as the semester continues, but the lab will provide you a soil test report with numbers and maybe some recommendations to it. Here's just one example for A&L Lab in Fort Wayne, Indiana. And you can see there's 2, 4, 6 samples here, and there's a bunch of numbers associated with it, okay? So just to kind of think a little bit through here, what do these numbers actually mean? And it couldn't be overwhelming looking at this and knowing what to do with this, but one of the goals, the learning objectives throughout the semester is for you, once you leave here, to be able to look at one of these reports and be able to know something about it, understand what some of this means, and then be able to make some recommendations or at least understand the soil and the pest management a little bit better based on the numbers that are provided in this sheet, okay? Before we do that, and this is not all going to happen. I'm not going to turn you into an expert in a week's time. I'm not going to turn you into an expert, at the end of the semester. You're not going to be an expert, but you should be exposed to some of these ideas and have a much better understanding, okay? And again, this is really this piece right here, not this particular soil test report, but being able to look at this and make heads or tails of it is a really important goal. And that's what we're going to be trying to do and working at over the course of the semester. Okay, so, but before we get there, let's back up a little bit and talk about some of the objectives of soil health or soil testing. Okay, so again, soil testing can be used for a number of things. We typically use it as an index of nutrient availability. So again, it's going to give you some idea of the portion of a nutrient in a pool that is plant available. It can also provide an index of nutrient loss or transport. So typically, this is particularly important for soil test phosphorus. Phosphorus, we have lots of issues with that, which we'll get into as the semester evolves. But higher testing soils are typically more susceptible to losses. And then thinking about predicting the profitability, or at least minimizing the risk from kind of a business or return on investment perspective of, if we actually apply fertilizer or lime, is it going to do anything for us? Is it going to say pay off in increased yields, or is it going to provide a better stand, or make our planting establishment more successful, things like this. Okay, so these are the types of things that soil tests can provide. Okay. Anytime we think about soil testing, there's some factors to consider, and these are just kind of 4 key pieces. We need to think about the depth, the time of year that we actually pull that soil sample, the frequency or how often we do that, and then the area that we're going to sample. Okay, so we'll talk about each one of these now. Depth is really one of the single most important factors in soil testing. If we don't control for depth, we have a lot of problems in terms of the information, or not knowing what information we actually get. So soil tests, and there's no perfect depth, there's no right or wrong answer here, but consistency really is key. Most of the recommendations in Ohio are based on an 8-inch sample, a 0 to 8-inch sample. And some people pull 0 to 6-inch samples, or 0 to 4, or even 0 to 5. Again, there's not a right or wrong answer here, but it's about maintaining consistency and then finding reference to materials that are based on this information. So again, Ohio historically has had a 0 to 8-inch sample. This has historically been essentially the plow layer, when how far down a plow will go and invert the soil. So this 0 to 8 inches is essentially considered as the mixing zone, that soil that gets kind of mixed in kind of an annual crop perspective. Depth is really important. You can see over here a few different managements of no manure, 40 pounds of P per acre per year versus up to 110. And this phenomenon happens, which is called soil stratification. This is a naturally occurring phenomenon in soils, but it's particularly important in kind of agricultural settings and thinking about tillage and soil testing. But essentially what happens is stratification is what happens when nutrients at the surface, or pHs at the surface, or whatever your variable might be of interest at the surface, is enriched, has higher numbers relative to lower levels, right? And that's very common in soils in general. And it's very common, especially for soils that, in this case, have a history of, say, manure application. So if we sample, in this scenario, if we sample these soils to 5 inches or to 10 inches, we can get very different results because of the nature of that kind of non-linear response as we go through the soil. Okay, so typically when we sample a more shallow sample, say 0 to 4 inches, we're going to get higher soil test numbers than if we sample 0 to 8. That's almost universally true. So again, the sample depth that we pick is very important. 0 to 8 is typically what is reported in Ohio. Okay, other factors to think about. Time of year. So typically we sample, and most soils are pooled in either early spring or in fall. Fall is by far in Ohio the most common time that samples are pooled. Soil testing labs run 60-70% of the total soils sometime in September, say through late November. It's about a 2, 3, 4 month period where they're doing vast majority of the work. So this time of year, they're really ramping up and starting to get a lot more samples flow through the lab. Okay, and we pick early spring or fall because it's a period of time when crops aren't actively growing. Okay, even if you're, say, in a perennial or a pasture, some sort of system that's not an annual system, if we pick early spring or in the fall sometime, typically that crop has kind of done its thing and there's not a lot of active growth going on. Okay, again, whether you pick early spring or early fall, we're going to suggest that you pick a time of year and stick with it. Okay, frequency. We recommend every 3 to 4 years for a soil sample, and if possible, sampling the same time within a rotation. So as an example, I've put here, if we've got a corn, soybean, and then wheat, after that wheat crop, we might soil sample going into, make any adjustments going into corn, and we might do that every 3 years, okay? Um, Alternatively, if we had a corn, soybean rotation without wheat, it might be corn, soybean. After that second soybean crop, we would soil sample. So that would be a scenario that might be every 4 years, okay? So that, obviously there's more rotations in Ohio than just those two I mentioned. So we can think about a lot of different possibilities, but typically every 3 or 4 years is what we would recommend. And then this final consideration, which is complicated. This is the tricky one. It's the area. How do we actually sample, and what do we do? So that we have a whole field, the zone sampling, and a grid sampling. We'll talk about each one of these in a bit. One of the take-home points here is that, we basically recommend that whatever the field is, that one soil sample represents no more than 25 acres, okay? So 25 acres is kind of this magic number of, we need a soil sample to represent no more than 25 acres. And that's even a stretch, really. I mean, there's a lot of sampling that happens that is much, much less than 25 acres, okay? So thinking about the area to sample, here we have a hypothetical field where we might have had a barn here, which is an old farmyard. So we might have some really history with a lot of confined, say, livestock in a lot here, in a paddock, and they've deposited a lot of manure, and that's really enriched the soil nutrients here. We might have a saline area, and then kind of an upper slope and a back slope or something. So we can imagine, whatever the scenario, that there's heterogeneity or variability within a field, okay? So the three approaches we talked about, this whole field sampling is where we'd actually go through and we'd go and pull a sample, a core from here. From here, there's, all these little circles represent essentially a different place where we might actually pull a soil sample, okay? And when we do that, and we kind of do it randomly or haphazardly, we can see that we might select some of these, unique features across the field. And then when we're taking multiple cores, that's all going to essentially get kind of mixed together and averaged together, okay? So that's one approach. Grid sampling is when we go out and we systematically lay a grid down on a field, and then we essentially sample each one of these grid points, okay? So we don't really think about the history, we just kind of lay a grid down and then we do the sampling. And then with zone sampling, we typically, it's kind of like grid sampling, but not to the same extent, where we based on previous knowledge, we might break the field up into these different zones. So here maybe zone 1 is this upper slope, zone 2 might be the saline area, and then zone 3 might be this kind of lower slope area, okay? So again, conceptually, three different approaches here. By far, there's plenty of people that still do kind of whole field sampling, but by far, the most common approach is grid sampling and zone sampling, and there's quite a bit of both that happen, okay? Whole field sampling is fine for maybe a little bit less intensive systems, or fields that don't have very much variability. And so when they don't have variability, or variability is kind of dealt with, and then it becomes more and more homogeneous over time, a whole field sampling would be perfectly sufficient for a field like that. So all of this is very, field or site specific. Whole field sampling. It's best if a single fertilizer recommendation will be used. So there's really no, we'll get a little bit into like the variable rate piece later towards the end of the semester. But if you don't have capacity, if you're not applying, if you're just going to go to a field and apply a flat rate of phosphorus, then doing things like zone sampling and grid sampling might not be, of great advantage to you. It's by far cheaper because you're only pulling, a soil sample per field as opposed to multiple samples. It provides no information about spatial variability across that field. Or if you're in an unusual area like that, say that where the old barn or paddock used to be, for example, if you sample those, then you might drive your values up. So you don't really have any idea about that. Here, no more than one sample every 10 acres. There's no right or wrong answer to this. Like I just told you 25 acres. I personally prefer 10 acres. I often tell people 10 acres. Kind of the official stance of OSU Extension is 25, and that's kind of what we've maintained. But really, every 10 acres, I mean, that's that's even a pretty large area for a single soil sample. A key feature here is that everything we're talking about, when we say a soil sample, we're talking about not just taking a single slice and from one actual spot in the field. We're always talking about taking multiple cores or multiple spades, mixing them and forming what we call a composite sample. So a composite sample, even in a whole field sampling here, you can see each one of these dots, there's a zigzag approach. Each one of these dots is a different core that is put in, say, a same bucket or a bag mixed together, and that's going to represent a soil sample. So again, we call that a composited sample. It's composited across multiple cores or spades or sharpshooters or whatever tool you're using to pull that soil. Zone sampling, again, requires some previous knowledge or management history, understanding what the field yields. We can divide fields into small, similar subunits or into subunits based on things like how it's historically been managed, what the topography is, the slopes and the aspects, the soil type, if we've got soil maps, the drainage classes, based on, part of the field is systematically tiled, part of it's not, or using yield maps, which is a very common approach, looking at higher yielding areas of the field versus lowing, and then lower yielding, and then taking, essentially breaking up the field into multiple subunits from that. So that's zone sampling. Best used for management may differ across the field. We still need georeference borders or zones. We have to, essentially say, well, it's in this part of the field, or zone 1 stops here and zone 2 starts here. It's a better assessment than a whole field. It's It's based on, that knowledge that you might have. Okay. So moving on to grid soil sampling, it's important when nutrients applied in that field may vary. So in other words, variable rate application. Okay, so the field's not getting the same flat rate across the entirety of it. It's very good and often the preferred approach when you're moving into a new field. Say you're renting ground, you buy a farm, and you have a new field with no really unknown history. It's getting managed by a different farmer or whatever it might be. Gives you a very good assessment, but it's more expensive. You can, if we flipped back here, we can see that we might have more soil samples in a grid sampling than zone. Here we have 3, and here we have many more than 3, okay? So for grid sampling, there's really kind of 2 approaches. We can think about cell or point samples. Cell samples are when we actually take soil samples across an entire cell, represented by, these dots would be soil samples across this entire grid cell. By far more common to do is this point sampling, where you basically find points on this grid, and then we're going to sample within some sort of radius, 10 feet, 20 feet, whatever it might be, around that grid sample. So this is really common practice in the industry today. Would be go to that kind of intersecting grid line, and then you actually pool multiple cores, composite those cores, and there's your soil sample for that grid point. Okay. So how many samples do you need per acre? I get this question all the time. There's, again, no right or wrong answer to this in many ways. Very common is what we would call a 2.5 acre grid sample. And now what that means is there's one composited soil sample for every 2.5 acres, okay? There's folks that do 2.5 acres per soil sample. That's not resolute enough. I'm going to do one sample every acre. I'm going to do a half acre sample. So there's all kinds of things, hybrid approaches and things that are out there. 2.5 in Ohio is very common. You see sometimes people do 4.5 or 5 or something like that. This is an example, kind of an extreme example, where coming at just some work based on nitrate, which is a very it's an incredibly variable nutrient in soil. But here's an example when we have 4.2 samples per acre, okay, and then we essentially take those samples and we make this pretty map, which we would call an interpolation map, okay? And so it's a heat map of sorts that shows the range of values nitrate in part per million. So this is a concentration of nitrate nitrogen in soil, and it goes from 5 part per million, this kind of dark blue or purple, all the way up to red, which is over 65 part per million. When we take 4.2 samples per acre, at least in this field, you can see there's variability here. And that's a very high density. That's like essentially quarter acre grid samples. So that would be very, very unusual to find in like somebody practicing that on a widespread basis. But then we can go even crazier and increase the density by 10. So instead of 4.2 samples an acre, we do 42 samples an acre, which is like what you might do for research, but no farmer's ever really going to do that. And you can see, bada boom, this is probably picked as an illustrative example, but you can see a lot more of these higher zones pop up in the middle that essentially were completely missed when we had a lower density grid. So again, we would call this a high density grid sample, and relative to that, this would be a lower density grid. Okay, so even with this, the point of this is just trying to illustrate that there's a trade-off. There's always a trade-off in grid sampling and soil sampling in general, where you collect more samples, it's going to take more time, and it's going to cost more money in analysis, but you're going to get better information, higher resolution information. The question is can you actually use that? Is that information going to help you and help management, help save money or return anything on that investment? Knowledge is very, very valuable, but sometimes if you can't do anything about it, it's good to know, but sometimes you can't do anything about it, then it might be not as helpful, or might not be worth the investment. So again, these are kind of decisions growers have to make all the time. And with grid soil sampling, there's always this trade-off between the costs and of collecting that soil and analyzing that soil versus the information you get. Okay, so important considerations. Recommendations typically say on a one sample per acre, for example, we would recommend every 10 or 20 years you might want to do that for SOM, soil organic matter, and CEC, this cation exchange capacity we talked about. Okay, maybe every 5 or 10 years we might do that for pH, and then every 4 or 5 years for nutrients. Okay, so this is a function of showing how buffered the soil is. Nutrients might fluctuate a little bit more commonly, or a little bit more variable over the years, and fluctuate quicker in a sense than something like pH, which might take a little bit more time. And then something like soil organic matter and CEC, that's going to change much slower than something like, say, soil test phosphorus. Okay. Again, so there's like some guidelines out there and recommendations, but sometimes this is really just about, what that company or the industry is going to do, what that retailer recommends, what the farmer wants to do. There's a lot of different things that go in the decision making of how dense or what is our grid sample density, okay? Some precautions, and this is true for not just grid sampling, for a lot of things, but we always need to take into account patterns in the field. If this is a graph showing distance across the row, phosphorus, extractable phosphorus, and then different either banded or broadcasted fertilizer at different rates, 75 and 45, band and broadcast, okay? So we can see when things are banded, that is, they're placed in a concentrated strip, often through the planter when you're planting seed, we can get much higher or greater elevated soil test results than, which is right here, than if, it's broadcast, okay? So the broadcast ones is this kind of gray triangle. I know this is a kind of a terrible picture. Gray triangle in this open square. We don't have those peaks that happen with this banded at 75 and banded at 45. So when we're taking soil samples, we need to, account for this and try to avoid these areas if we can, or at least be aware of it. So, there's just some cautions because what can happen, I said this is industry practice in terms of taking point sampling, but what can happen sometimes is people will, and we'll show this in just a second, but drive kind of just like an automated soil sampler and drive straight in a line and take soil samples. So that's problematic when we're thinking about this kind of banding scenario, okay? So soil samplers, we'll show, we've got a video about soil sampling, but there's, different tools of the trade here. This would be called a soil probe. They often have much, sometimes have steps, much longer handle, but we, direct push this in the ground. There's this window for to a specified depth, 8 inches would be common. And then we extract the core from this, this kind of little sleeve window. We can use things like augers here. This is what we might call a Dutch auger. There's lots of different things out there. This is a kind of an automated thing that I'm talking about, where there's a hydraulic engine back here and a tank, and then instead of him having to get out, there's a direct push probe that goes in and captures this sample, okay? And so again, a lot of different things. We can make this process faster with automation. This YouTube link is showing just a real short link of showing you how this automated sampler works in terms of being able to kind of just collect a lot of different soil cores and allowing somebody to go out and really to a field or a set of fields and take soil samples all day long without getting, without kind of the backbreaking work of that. So people have, not surprisingly, found ways to do this more efficiently and faster and cheaper. There's also deep core samples. Here's another video that you can look at if you like to see it. So there's different things out there for taking samples, all right? Then I just want to end on this concept of adaptive nutrient management. This is really important for soil sampling. So this is really a concept of thinking about adjusting management based on soil testing information over time, okay? And so it requires some key pieces. So we have to maintain consistency with how we soil sample. Did we soil sample to the same depth? Did we go the same time of year? Did we do it like we did it last time? Did it go to the same lab, for example? Do we have records of what we did 3 or 4 years ago and how we sampled and the soil test results from 3 or 4 years, okay? If, soil testing labs are very happy they typically keep very excellent records and are happy to provide results from previous years or what have you. But the idea is like, you might look at what your soil test trend was 10 years ago, and then look at it again, what it was, say, 6 years ago, and then maybe, 4 or 3 years ago, and what it is this year. Based on those trends, you might make tweaks and changes. This is really important because we as a university can provide you with recommendations and tell you, if your soil test value is this, you apply exactly this much fertilizer. But people that are in the industry and have experience with this understand that soil sampling analysis is not this precision science, right? Like, if you tell me your soil test level is this and you're growing, say, whatever crop it might be, I can approximate what your soil test might be based on, say, removal rates and this and that in 4 years from now, but I might not be too close either. So there's, it's not, again, not a precision science. There's a bit of art and a bit of just uncertainty in terms of this. And so, especially when, and we'll talk a little bit about this in the next lecture, but thinking about what is happening in your system in that field, what have you been doing, what's the soil test trends over time, are they increasing, decreasing, maintaining, and then are you going to do anything about it, are you going to tweak or change? But the problem is, if you do not maintain consistency over time, you really don't have the ability to truly assess what's happening in your system, and from, if you're farming and thinking about it from a business perspective, you don't really have any way of understanding, are there opportunities to control costs, opportunities to, to maybe save a little bit on fertilizer, or maybe your soil test levels are trending down, so you need to think about, investing a little bit more in fertilizer, for example. So these are all things that need to be considered, and it's all kind of wrapped in this idea of adaptive nutrient management, which considers this temporal component of what's happening to your field or your soil test levels over time. Okay, I'm going to stop there and continue with plant analysis next week.